looking at reactions of acid halides, okay? The possible reactions can undergo. So remember that acid halides can be represented as what? RCOCl, okay? So to carry out these reactions, we'll start with the first reaction. Reaction with alcohols, okay? So these acid halides can react with alcohols. Remember that this is acid chlorides plus alcohol. This can react to give us an ester, okay, plus water. Sorry, plus HCl, not water, plus HCl. Okay, so what happened here is simple. So when you have this, the chlorine and the hydrogen will react to give us this. Why this will combine with this to give us this. So for the sake of clarity, I can put prime here to indicate that this is how it happens. Okay, so in this simple reaction, now let's do an example. If I have CH3COCl plus, let's say, methanol, for example. If you look at this reaction, what you're going to have is an ester, which is going to be CH3COOCH3 plus HCl. So you're going to have methyl ethanoate in this reaction. So the number 2 reaction is reaction with ammonia. Okay, so it's going to react with ammonia to form an amine. So so in this reaction, I'm going to have RCOCl plus NH3. So in this reaction, this thing will break up as NH2. You have amine and hydrogen. So the hydrogen will pick up the chlorine to form the HCl. So this will combine with this to have RCONH2 plus hydrogen will go with chlorine to form what? HCl. So in this, if you look at the reaction, you will see that what is produced is an amide. So this is called an amide, not just an amide. What we have here is a primary amide. So an example is using CH3COCl plus ammonia. We have ethanamide, CH3CONH2 plus HCl. Okay, so the third reaction now will be reaction with primary amine. Okay, reaction with a primary amine, or you can say reaction with amines. Okay, so reaction with amines with amine, the class is going to form. The class of amines is going to form. So in this reaction, if you have RCOCl plus a primary amine, this is a primary amine. Okay, this is a primary amine. So when the reaction happens, the hydrogen will pick up the chlorine to form HCl. So what will now happen is that let's differentiate this R and this R with prime. So if one hydrogen here picks up the chlorine to form HCl, then what is left will now join together with this. We are going to have RCONH R prime, something like this, plus the HCl. So this is what we call, this is an amide. This is an amide, but it is a 2-degree amide. It's a secondary amide. Take note of this. So if you look at this one gave us a secondary amide, okay, because I have 2R. But this one gave us, with ammonia, gave us a primary amide. So that is the reaction involving this. The next reaction of acid chloride is the famous Friedel-Crafts acylation, okay? Friedel-Crafts acylation. This is simply the reaction of an acid chloride with benzene in the presence of a catalyst, a Lewis acid, okay? So example is aluminum chloride. You can use aluminum chloride or aluminum bromide depending on the reaction. So example, if you have CH3COCl reacting with benzene C6H6, okay? So this reaction is catalyzed using the corresponding Lewis acid, which is aluminum chloride, or you can also use iron 3 chloride. So in this reaction, remember that what you're seeing here, benzene is the same thing as this, okay? And this is the same thing as CH3COCl. So this is also how the reaction looks like. This represents this represents this, okay? So in this reaction, there will be a formation of a ketone, right? So what will happen here will be, what is taking place here is an electrophilic aromatic substitution reaction. The electrophile from this acid chloride will substitute this guy, so one of the hydrogens here. So you're going to, for this sake, you're going to have C6H5. Why is it H5? Because one of the hydrogens here will be replaced with the acid group, the AC group, which is this group here. So we'll have CH3. Then the chlorine will combine with that hydrogen that is here to give you HCl. Now, if it's taking place in this form, this AC group will still be on top of this benzene. So you're going to have something like this, So you have COCH3 plus HCl. So these two compounds are the same. Okay. So you can call this. The name of the compound can be called methyl phenyl ketone. Okay, you can call it methyl phenyl ketone. Okay, so this is the product of this reaction. So what is taking place here is a substitution reaction on the benzene ring. The AC group will substitute one of the hydrogen. Remember, there are 6 hydrogens here. So one of the hydrogens will be replaced with the AC group here to form this aromatic substituted compound. So this is a reaction of acid chloride with what? Aromatic compounds such as benzene to form this compound you're seeing here, which is the same thing as this compound.